Hello friends, in this video we will solve this question from CSIR NET exam. For the following reactions A and B, the correct statement is, we have this reaction, and in this the reagent is potassium tert butoxide, which is in excess. In here also we have potassium tert butoxide in excess, and these are the reactants. Since excess of base is used, the carboxylic will be in the form of carboxylate. Let us draw this reactant, which is in of A, into the chair form. And while drawing the chair form, this tert butyl group, it is a bulky group. And the bulky group in the chair form, we draw it usually in the equatorial position over here, as it provides stability to the chair form. So once you draw it here, okay, now let's check where the bromine will come. So it is 1 carbon, 2, 3 and 4. So okay, the bromine will come here. Now in this case, the bromine is shown above the plane of the paper. Above the plane of the paper means it will come into the axial position over here. Axial position because the axial position over here, it is pointing upwards. Since it is facing upwards, it is above the plane of the paper. And we should also know that there is a hydrogen over here. Okay, it is the hydrogen over here is in the equatorial position, and it will be below the plane of the paper. Next to this carbon, we will have the carboxylic acid group, and if you observe the stereochemistry over here, it is shown above the plane of the paper. Now above the plane of the paper means we are having two positions here. This is the equatorial position and this is the axial position. Now the equatorial position over here, it is facing upwards. Since it is facing upwards, this is above the plane of the paper, and this axial group, which is facing downwards, it is below the plane of the paper. Since the stereochemistry here is above the plane of the paper, that means the carboxylic acid group is placed in the equatorial position as shown here. And now we should know that there is a hydrogen group in the axial position over here, which is below the plane of the paper. So this is the chair form. Now what we have to observe, this bromine group and this hydrogen, they are anti-periplanar to each other. It is in the axial position, this bromine group, and this is in the axial position, so they are anti-periplanar. So elimination will happen with these two. The tert butoxide group will attack the hydrogen over here, this bond will fall here, and the bromine group leaves. So there will be a double bond coming here, and the carboxylic acid group, it is there in the product. So just now we have witnessed E2 elimination easily by giving the cyclohexene and with the carboxylic group. In case of B, let us again draw it in the chair form. Tert butyl group, as usual, it will be in the equatorial position for the chair form to be in the stable form. Now bromine group over here, it is shown above the plane of the paper as described earlier. It will be in the axial position again. Very next to this carbon, we have this carbon, and it will have the carboxylic group. Now here it is shown below the plane of the paper. Since it is below the plane of the paper, the axial group over here, which is facing downwards, it is below the plane of the paper. So the carboxylic acid group will be placed here, which is below the plane of the paper. In this reaction, it is interesting to note that the carboxylic group itself is anti-periplanar to this bromine. So now in the elimination step, these two groups will be eliminated in the following way. This negative charge falls here, this bond falls here, forming a double bond here, and this bromide group leaves, involving the decarboxylation. So we will have elimination of the carbon dioxide and one bromide group, and we will have this product. In this we are having a product without the carboxylic acid group. So just remember, whenever they are anti-periplanar to each other in the opposite direction in the axial group, those ones will be eliminated. So option 2, where A gives this product with the carboxylic group and B which gives this one without the carboxylic group, will be the correct choice.